Okay, ladies and gentlemen, for those that are with us already, if we could just wait a few more seconds and for a few more to join us. Quite a few people are registered, so we'd like to give everyone a chance, just a few seconds, and then we'll get started. Thanks very much. Okay, now that we're all, there's a lot of people still joining, but we'll carry on as it's not fair on the rest. So first of all, welcome everyone. Thank you for joining us for the second of 3 webinars. Hope everyone's well and everyone's safe, and we'll go on. Okay, the webinar, like the first, will be recorded and we will publish it on the YouTube channel. All of those registered and all of those listening in will have an email. We'll send an email with the link so you can see it afterwards and you can share it with colleagues and do what you want with it. Questions. We welcome all questions from anybody. Please ask us anything. What we will do with the questions after the 3 webinars have been aired, we'll put the questions on the website, questions and answers. We won't put names so you can ask what you want, and we'll publish those so everyone can see the answers to the questions. So we did the first one last week, the health and safety webinar. Again, if you weren't registered for that, we will share a link with you so you can go and see that on YouTube. This one today obviously is on productivity, and today we'll show you more about sonic drilling and the technique and how to achieve what you need to achieve. The third webinar will be on the UK experience, and that will give you true examples from the drill site, and we'll have a guest speaker from Borehole Solutions who will actually talk you through their experience. 3 of us will be talking today. There's myself, Callum and Rutger. What I will do is, please ask, I'm going to ask you please to bear with us. There's myself sat in Bromsgrove in the Midlands. There's Callum sat on the South Coast, and Rutger is in Holland. So we are doing this remote, and we hope to make it as smooth as possible, but bear with us. Okay, a little bit of an introduction to Eijkelkamp Fraste UK. We were launched in 2019. The reason we were launched was to answer the demand of the UK drilling community, who, first of all, those who've got Fraste conventional rigs, we look after those. We sell new, and we also look after everything that's already in the UK. And we do the same for Sonic. We sell Sonic rigs, CPT rigs, as it says there, and we also support those that are already in the UK, and we'll continue to support all customers for both Fraste and Sonic sand drill rigs. We're in a very good position just in the centre of the UK, very close to the M5, M6 and M42. So if you are passing, please call in. If you need support, if you're anywhere close to the area, please call whenever you need to, and we'll do what we can for you.
So this is Rutger presenting from the Netherlands. We often get asked, what is 150 Hertz sonic? Well, the theory is that sonic drilling is a soil penetration technique that strongly reduces friction on the drill string and drill bit due to liquefaction, inertia effect, and temporary reduction of porosity of the soil.
We're going to start by taking a closer look at how sonic works. On the far right, you'll see a diagram which shows 2 counter-rotating eccentrics at the top. These can run at a max speed of 9,000 RPM. One runs clockwise and the other anti-clockwise, and this is to ensure a central movement. The high frequency force is directed along the axes in order to keep everything vertical. The drill string is brought to a vibration frequency of up to 150 hertz, so that's 150 movements per second. And it basically moves so quickly that the soil simply cannot react. We call liquefaction or fluidization occurs. This is a very thin layer of soil particles directly surrounding the drill string to become a fluid powder or paste, which significantly reduces the friction. It's around 1 to 2 millimeters thick, and this is the only area to be affected. Everything else will remain completely untouched. The technique is the ideal solution for alluvial conditions such as sands, gravels, and clays. The photo on the left there shows the perfect core sample of an engine block, which was taken at a landfill site using one of our compact rotary sonic rigs. It's just one example of what can be achieved when using the 150 hertz sonic equipment. Here we have a diagram on the right with an overview of the different materials you can drill. Starting on the right with what would commonly be found in Holland, your soft alluvial formations, and then across to those more often seen in places like Scotland, for example, boulders, moraine, and bedrock. Compact or hard materials such as compact sand or rock, where there is no space between particles, you can apply rotation, and this will give you a really efficient hammer. Compared with conventional methods, sonic provides a far lower risk when drilling through mixed formations. You basically have much less to consider. The photo on the was taken from the demo day when one of our rigs drilled through a concrete slab with a 20 mil thick steel plate, and it took around 6 minutes from start to finish. Next, we're going to look at the advantages of using sonic for sampling, and then the different barrels that we offer to cover all types of overburden formations. Starting with the benefits of sonic for sampling. Firstly, nothing is lost. You really do see what's in the ground. Some examples are shown in the photos. The top right shows boulders and gravels. Below that, you have hard clay to mudstone. And then bottom left is peat going over to clay, which can usually be quite problematic trying to sample. There is no loss of contamination through heat. If it gets really hot, then your sample starts to evaporate. However, with sonic system, it should always stay below 40 degrees Celsius. Using the dual wall system, which we will come to shortly, you can keep the core cool whilst drilling. The second reason is speed. We had a client drilling with a GBRS wireline barrel in France and using a 3-inch barrel with 5-inch casing system and a winch for pulling rods. It's still quicker than you had for recovery. Compared to cable percussion or drilling, it's 3 times faster. An example of this was a company operating in London fairly recently. They spent 3 days chiseling through gravel layers, and it took only a few minutes. So ultimately, you're choosing between slower, more partial results versus better rates and sample quality.
So we're now looking at going more into the samplers. We have 3 types of standard samplers and then some variations on that. The first sampler we have specially designed for alluvial soils, which is known for high water content, very soft, but very difficult to take a good quality core sample with. This Aqualock is a piston sampler, which you bring to the sampling depth, then you can open it, which we'll see in a minute. If you look at the pictures of samples in the bottom, the left one, it's a typical Dutch sample, sands, with a layer of gravels and then sands again. Nothing is disturbed and also nothing is lost, and you get a really good quality core sample. On the right, you see a hydrocarbon contamination in a sample, and also there's no mixture of the material. Everything is where it's supposed to. And if we go to the next slide, we'll see how this works. So it's a piston operated sampler, which has a water column to keep the piston at the cutting shoe. If you want to sample, you open this valve with push pipes. The water can escape, the piston will stay where it is, and the Aqualock will slide over to take that good quality core sample. If you did that and you have the sample, you'll close the system again, and when you start pulling it to surface, it will create a vacuum on the sample that tries to fall out, but as it's a vacuum, it will stay where it is. Then at surface, you'll connect either a adapter to a liner, so you can push it over, or we can push it straight into a sample gutter. With high pressure water, we can push the piston to the front of the sampler, pushing out the sample and giving that good quality core. If you did that, if you pushed out the sampler is ready to go for another run. So the beautiful thing of this sampler is that you don't require casing, as when the piston is at the cutting shoe, there's no material coming into the sampler unless you want it to. So if a borehole collapses, the fallen material will be pushed to the side, and once you're in virgin material again, you open the sampler and you take a nice core run.
For alluvial, drier and fairly hard materials, you can use the single wall core barrel. It's still possible to sample dry, including difficult layers such as cobbles and pebbles. We have many clients using the system on landfill sites, as you can see in the photo below. You have stockpile of building materials, crushed bricks, concrete and steel rebar. Almost impossible to sample with conventional equipment, as you cannot use mud due to the cavities, but with Sonic you can obtain full recovery. Over to the image on the right, this shows a client who was drilling for mineral exploration, starting with soft clays and then onto bauxite. With the barrel, it's also possible to carry SPT, pressure metering and CPT testing in between Sonic sampling. A diagram showing you how the barrel and casing is installed. With an open system, i.e. no casing, the hull will of course collapse. You run the sampler first, then your casing, and repeat until target depth. The casing is installed with water or air flush, and this is to remove the lining, which would usually get stuck between the casing and the sample barrel.
Then we go to material, which is getting harder. So from very hard layers up to moraine geology, glacial material, and then even bedrock. There is a possibility to use a sampler which has a double wall. So in between that wall, we can apply water flush or air flush to be able to cool the bits and to wash out cuttings. Then there's two types of bits we can use. On the left, you'll see a side discharge. This bit makes it possible to use a water or air flush without washing away the fine material. So it washes it to the side or up the hole, and it will not disturb the sample. Then on the right bit picture, there is with a from discharge. This from discharge allows full cooling capacity, and that is used in full rock. Then if you look at the sample picture on the right, this is a granite boulder, about 260 MPa hardness, then going over into soft clays. And it's also possible to take a good quality core sample in this situation. So they use the water flush to core the boulder. And once they notice to be in softer material, they turn off the water, so they can still core that softer clay material but dry. And as you can see, nothing is lost, nothing is mixed, and everything is taken into the sample. So over here we show how that works. So we have the possibility to cool the bits and to wash out cuttings with the side discharge sampling bit, then going through a harder layer. And then once that is done, as it's an open borehole, we want to stabilize it to take the sample to surface. So we install a casing, and that casing prevents the borehole from collapsing. Then once that is installed, we can take the sampler back to surface, take out the sample, and go for another run. Once you've taken samples, the casing will also support the borehole, so you can use that open hole to do SPT testing or do other geotechnical tests. And then they continue usually with sonic sampling again. Over here, some videos on a site in London. This is taken with a SRS ML small rotosonic, which is a 6-ton unit. They're sampling some clay material. The video now playing shows how to take a sample. So they have the barrel in the ground, and they're getting to surface with the drill rods. The drill rods are now disappearing into the borehole, taking the sample. Once they've done that, then the sampler is taken to surface and they take out the sample. On this side, in between sampling, they also do SPT testing. And now if we show that other video on the right, so if you have taken a sample, the core barrel is taken to surface and they use the high frequency samples to also extract the sample. And that gives a nice sausage of that material. And then they can take a really good borehole description as all the material is there. As it's now showing in a gutter, we can also take the sample straight into a liner, so that liner can be sent to the laboratory.
Last week, we touched on the range of different in situ tests which could be carried out using the rigs. We have a swing-in hydraulic hammer for taking SPT tests. The rig also includes a digital blow counter. Cone penetration testing can be done via the main hoist feed cylinder or with the drill and CPT unit. If you hit boulder or hard layer, you can switch over really quickly, push through refusal, set casing and continue with CPT testing. It gives you a significantly cheaper setup for the one mobilization, and you have access to all of the data. You can also take UT100 and U100 samples. This is shown in the image on the left-hand side, and it's also possible to do pressure meter testing with inflatable packers. With our dual option, you also have one machine which can cover all formations. On the smaller models, we can fit a coring head with a single or two-speed orbit motor, which is ideal for proving bedrock or shallow coring. On the mid to large range, we have a 4-speed rotary head for deep coring. There's a range of motors to choose from with a max rotation speed sitting at around 1,000 RPM. We have a short video here on the right-hand side which shows how simple it is to switch between the two heads. The rig shown is our CRS XL140 Duo. You have the compact rotosonic head on the left, and then the 4-speed rotary head on the right. With the dual system, you can sample the overburden with sonic, shift the head over into position, and then continue with conventional rotary. There is a 2-speed electrical switch on the main console, and this will give you the low and high range option. And then there's also a mechanical lever on the head. This is shown here at the end.
So here we have an example of one of our clients working on the largest geotechnical project in the world, which was in New Zealand after the Christchurch earthquakes. The company ProDrill, they started the project with conventional rotary wireline drilling, and the geology is mainly glacial material with a lot of clays, sands and gravels, and some silt layers. When using conventional rotary wireline drilling, the issue was that they had very poor recovery, and they missed quite a lot of the material they were sampling. Average production was about 15 meters a day, including sampling and SPT. And due to the abrasive sands and gravels, they had a lot of wear and tear on the tooling. And well, they thought of how to improve and started drilling with sonic. Immediately, they had full recovery core samples, including the layers which were sensitive for liquefaction, which was a silt layer throughout the area. And they had full recovery also from the cemented gravels, which they struggled on before. But what was really the benefit from them was not only the core recovery, but also the increase in daily production. So on average, they were doing 50-60 meters of sampling with a 3-man crew. Yeah, the tooling wear was pretty low. Bits were the ones which were wearing fastest, but even that was way less than what they were using. And the owner of the company, Russell Sherwin, said that with the sonic use, they went up to 100% core recovery, and they dropped their operational costs by 75%. And from beginning of this year, they cored 430,000 meters with sonic. And if we recap on what sonic can do on sampling, so it gives really good quality full recovery core samples in all the overburdens, including the very difficult ones like gravels. It can sample of all also consolidated formations, and it's perfect for materials in landfills and mixed construction debris. And it also is used for taking samples of proving bedrock. Now, the sample you see on the right is from a project of a client in Sweden. Sweden has about 5,000 man-made dams, and the issue is that these dams are eroding. To construct these dams, they used all the local material they could find, consisting a lot of moraine and glacial material, including very big boulders, gravels, and sand. The only way to efficiently sample this material and to get full recovery, so to get the full image on the quality of these dams, they could use sonic. No other technology gives a better sample quality in that. And yeah, as you see, the driller was very proud on the big boulders he took out of the geology.
Okay, that kind of covers all the slides for this particular webinar. As we said earlier, there is a third webinar exactly a week away and the same time at 2:30. And what we will do then, as I said previously, is we'll tell you about sites in the UK, pardon me, and experience of drillers in the UK. And that will be brought to you by a guest speaker from Borehole Solutions, who is operating 4 sonic rigs in the UK at the moment. All of that so far must leave you with lots and lots of questions, so please send them to us. These are our details, and I'll leave these on the screen for some time. Ask any questions you want. Everything we will publish, we won't put names against the questions, so that you know, ask if you think it's a stupid question. It's not, so please ask it, and we won't put names against them. Anything at all you've got, any questions, or if you'd like us to cover anything else in the future, please ask, and we'll do that for you. Thank you very much for coming along to this today. Please come next week, and stay safe and stay well. Thank you very much.